We have been talking about decarbonization, digitalization, and shipping. And now we are going to shift our way of seeing things and discuss about carbon capture, utilization, and storage. We are going to see the role of shipping from two different angles. The first one as an emitter with the potential of capturing CO2 and reducing it with this kind of technologies, carbon capture technologies. And we are going to see shipping as a method to transport CO2 for utilization or sequestration, as the means to connect the dots of the carbon capture utilization value chain. So with us today, we have very different stakeholders coming from very different positions, from shipping companies, from CO2 midstream solution providers, emitters, technology providers, and of course, companies that could offer sequestration sites. So it's going to be a discussion to reveal challenges and opportunities, not only on a global scale, because shipping is global, but also for the Mediterranean region where we are standing. So with this, I would like to thank all the panel for being here. Mr. Kalogiratos, Director and CEO of Capital Clean Energy Carriers Corporation. Mr. Jasper Heikens, who is Chief Commercial Officer of Ecolog. Ms. Eleni Polychronopoulou, President of ERMA First Group, President of Chemexpo and Vice Chair of SES Europe. And Mr. Nikolas Rigas, Head of Carbon Storage EnEarth, Energia's new carbon storage and decarbonization vehicle. And Mr. Daskalakis, George, Head of New Technologies, Director General of Strategy for Motor Oil. Starting on, how do you see, and that question goes to all panelists, how do you see the role of carbon capture, utilization, and storage evolving in the next 5 to 10 years to achieve climate change goals? And also, how does your organization, from the different perspective that you stand for, can fit in this scale-up process? Starting with you, Mr. Kalogiratos.
Thank you, Chara. I think it's great to have a panel about not just about carbon capture on board, which I think is typically what has been the main preoccupation of the shipping industry, but also to understand the fundamentals of CO2, liquid CO2 transportation going forward. We do expect that this is going to be a major market for many reasons. As many of the climate goals that have been set some time ago are now stalling, I think increasingly the CCUS industry is being recognized as a method to achieve these goals faster. In a way, it's a low-hanging fruit. That's, of course, especially important for the hard-to-decarbonize industries, such as the cement, the refinery industries, chemicals, and others. It is important to extend the lifetime of oil and gas projects. It's going to be quite important going forward also for the voluntary carbon offset market, especially as AI has increasingly more power requirements going forward. We see many of the technology giants looking to offset their carbon footprint, so it's going to play a role there as well. But also, of course, potentially we'll have in the future, not necessarily today, as it still looks very expensive technology, direct air capture. So this, according to many analysts, is expected to be a major market, more than 400 MTPA, so more than 400 million tons per annum by 2030. And many analysts expect that about 20% of that, or a little more, could be transported overseas. In some markets, such as the US, pipelines are going to play a major role, but in other markets, in Northern Europe, Mediterranean, the Asia-Pacific region, maritime transportation of CO2 is going to play a major role. And we have positioned ourselves early in this market. We have ordered the first 4 liquid CO2 carriers of 22,000 cubic meters. These are the first of their kind and their size in the world. The idea is to provide to the CCUS industry a reference point early in the game as still the logistics chain is being built. And just for you to have an order of magnitude, so the 4 ships together, assuming a short-haul trade from, let's say, the continent to Northern Sea or Norway, would be able to carry a bit less than 5 million tons per annum when, as I just said earlier, the market is expected to be 80 to 90 million tons per annum by 2030. So we're going to need a lot more ships.
Thank you. So moving to Jasper, I think that we have a good pitch here. So what about the business model? So what business model for CO2 terminals in the CCUS value chain for the Mediterranean region do you see most suitable?
Yeah, thank you very much. And thank you for inviting me to this esteemed panel. Ecolog is a new company, and we're focused on the midstream for the energy transition. So shipping and terminals for both CO2 and liquid hydrogen. Of course, we'll talk CO2 today here, but it's really trying to offer a service to customers rather than an asset. And we have several projects on the go now, and one of them in Greece, which is Apollo CO2. And this is our strategy around the Mediterranean, where we say, okay, let's try and aggregate as much CO2 in one central facility as possible to bring the costs down for the customer, attract funding, because that's a key requirement, and I'm sure that topic will come up further down in the conversation. Attract funding from the EU, attract funding from the Greek state, collect scale, and then it also allows you to attract larger ships. And that's also very important. And I'm very glad that Jerry next door to me has ordered these vessels, because that specific type is really required for CO2 to travel longer distances. So in the North Sea and Northern Europe, the distance between emitter and sequestration site is a bit shorter. In the Mediterranean, it can be a bit further. Of course, we have the site developed by Energean, which is great in northern Greece, but the next one is in northern Italy. Where is the next one going to come from? We don't know yet. But distances are further. So the further you travel with a cargo, the more volume you want to transport with a cargo, the better it is to have a big ship. To have a big ship, you need a big terminal, you need the volume, and that's really our view. Let's create this centrally aggregated facility, attract volumes, attract big ships, and reduce cost. It also allows kind of the phase 2 emitters to join, right? The smaller emitters, what do they do if there's no central location? And that's what we're trying to create.
Fantastic. I think that this gives a very good pitch for Eleni, Polychronopoulou, to discuss about the role of CCUS evolution for the next 5 to 10 years from a technology provider perspective. And also, why not, to tell us about how to achieve a commercially viable carbon capture utilization technology in this context.
Yes, we also see that CCS is going to be a very critical solution for the environment, for the decarbonization, because there are no silver bullets right now. We don't see any silver bullets, especially in shipping. All solutions are either economically or socially unacceptable technology solutions, and the alternative fuels are either scarce or very expensive. So in ERMA first, you might all know that we are developing the carbon capture systems and for ships. And what we see right now is that the biggest drawbacks are the possibility to offload the CO2. Actually, the shipping industry, I believe, is ready to invest in carbon capture. Yes, there is the constraint of the size and the energy and steam which is required, but if proper engineering takes place and proper feasibility studies and proper planning, emissions up to 15 and 30%, from 15 to 30% can be captured, and in this way the ships can achieve their goals. But if there's no possibility to offload the CO2 right now, it doesn't make sense to start any testing, any pilot testing. So we are very much looking forward to the development of projects in Greece, but also far from Greece, where the big vessels arrive and they want to offload the CO2. What's being done is a lot of research in all aspects, technology, and also what has to do with the offloading systems. What we are not doing enough, though, is we are not training our people. And just before Mr. Zolota said, what do you think about having a laboratory in the middle of the ocean? I will tell you, you will have a chemical factory in the middle of the ocean. So right now, if we say that we start installing carbon capture systems in a large scale, I can tell you that on board ships, always talking about ships, I can tell you that yes, there are engineering firms, there are vendors, ERMA First is one of them. There are shipyards, they have the experience because all these years, it has been also discussed before that the vessels have been installing all kinds of new equipment. Ballast water, scrubbers, energy saving devices, shore power connection, and so many other equipment on board. We can do the installation. But if we don't know where to offload the CO2, we cannot proceed. If we don't have the people, we cannot proceed. And for all that you are going for sure to mention later, we need a market viable model.
Thank you. So stepping to Mr. Rigas, can you give us your perspective on the CCUS value chain evolution? And in particular, how do you see the regional Mediterranean market of that kind evolving in this period?
Of course, and thank you very much for having me here. It's a very nice panel because we're going to get to hear, I think, every single different view for the entire value chain that we're sitting on. Jasper just talked about the storage sites and how far away they are. The question is, and what we should all be asking is, where we're going to store the CO2. We have currently in Greece 11 million tons of industrial CO2 emissions coming only from factories. Italy has alone another 60 million tons of industrial emissions. And currently, collectively, we don't have more than 4 or 5 million tons of storage capacity at the moment that is being developed. We are short on storage. And of course, we need to work together to currently kick off the industry. If we don't start somewhere, and if we don't start today, I think talking about 5 to 10 years down the line is looking a bit too far, because we need to work together as a value chain to get it kick-started. Once we've found the first storage solutions, once we've injected CO2, once we've captured it, we can start looking down the line 5, 10 years down, and what we're going to do with it, and where we're going to offload it with ships, and how this thing is going to become in a more larger scale. But we need to focus on the basics, which means develop the value chain today, store the CO2, get the industry kicked off, get the emitters on capture facilities, get the first ships built, get the gathering plants together, and start storing CO2. Once this is done, I think the oil and gas industry has proven that they're very capable of finding reservoirs. It's a matter of investing in it. It's a matter of finding the new pore space. In Greece specifically, as many of you are aware, we have only one producing oil field that is coming towards the end of its life. And that is going to be used as a demonstration for the first carbon storage site. We have an opportunity here, though, that we are the first in the Med at the moment. There's only 2 projects, and we can be, as a country and as a region, a key player in the Mediterranean. Once we've solved that, we can then continue, go down to Egypt, we can go down to Algeria, we can go down to other countries that have more mineral resources, that have produced oil, that have produced gas, and open up the market to more storage capacity. But I think the most important message from my side is to start storing CO2 and start doing it now, rather than wait and lose the train and lose the wagon for someone else to start injecting.
Thank you. And Mr. Daskalakis, your opinion on that, on the evolution of the carbon capture value chain in the Mediterranean, and what about the adoption of such technologies what kind of challenges you are now facing?
We were having this discussion, the same discussion last year, 2022, 2023. We would still have this discussion, but I would be very skeptical. Since the start of 2024, things have changed at the European level since the inception of the industrial carbon strategy, carbon management strategy, was introduced and became a document, formal document for the European Union. This means that the targets are there, the contribution, the expected contribution of this carbon capture has been formalized and has been set. And now the whole thing comes to the governments, emitters, storage operators, ship owners, pipeline operators to go ahead and materialize this and achieve the targets for the net zero. As for motor oil, we have been in this venture for the last almost 4 years, and we went through several stages. We are currently in the engineering of the carbon capture and use project, which we have the ability and we have the flexibility not only to capture CO2, but also to produce very clean hydrogen out of it. Since it is installed, it will be installed downstream. They are our main hydrogen production unit. This gives us two opportunities. One is for the pure decarbonization, since we will be capturing something like 25% of our emissions, but also we will be producing a very hydrogen of very low carbon intensity, which means that it can be used both as feedstock and as well as a decarbonization agent for the other units of our refinery, which cannot be decarbonized with carbon capture, meaning that we can use it as a co-firing fuel. This gives us very big opportunities, but again, we are challenged with the technologies. The technologies that are introduced are there, but they have not been tested in such a large scale, and which means that we don't have reference plants, which is very important for a mature industry like the refining. We usually, when the time comes to select the technology, we go and visit the plant. This is not the case right now. We only have proxy implementation of these technologies, meaning for us is the fertilizer companies which utilize, which they are producing SMRs and they capture CO2 for urea production. But still, it's not exactly the same case and not exactly the same specifications in terms of quality of the CO2 that's captured and the quantity as well. So we have very many challenges. When it comes to utilization of the CO2, which is something that we have introduced as a mean to reduce the captured, stored, shipped and stored, in order to provide something new. There the things are quite even harsher because the utilization projects and in more specifically the methanol production units are at the best pilot scale or large pilot scale. So although we are aiming for something in the range of 25,000 tons per year of methanol, this is not very easy to bring it in. So our challenge is there. We don't have references. We are trying to implement and materialize and engineer on new things. And for sure, the experience of the people involved, the experience of the contractors and the experience of technology providers is very, very, very important for this task.
Thank you for a very good pitch to Mr. Kalogiratos. So in the absence of reference projects, what are the cost drivers for CO2 transportation? And how do you see in the future how do you envision this reduction of costs to make it economically viable?
So the beauty and attractiveness of shipping in the movement of goods, it's cost effectiveness. It is a very efficient method of transporting goods, and overall, this is why the bulk of goods are being transported by ship today. So that becomes even more important when you carry what is predominantly waste, right? So this is waste management, maybe with the exception of the usage of CO2 when it comes to e-fuels, which is, I don't think this is something that is going to take off in big volumes in the near future. So the minimizing cost is an extremely important element in order for this industry to flourish. So what do we do in shipping, and that gets us to this very cost-efficient method of transportation? It's movement of goods in bulk and standardization. When you look at all major shipping segments, dry bulk, tankers, LNG or whatnot, you'll find that it is large cargoes moved in a very standardized way, specific terminals, very quick turnaround, loading and discharging, and so on and so forth. So this nascent industry, the liquid CO2, let's say, maritime transportation industry, has quite a distance to cover when it comes to standardization. This will be achieved by having the agreement of all stakeholders of how to set up terminals, as well as the technology of terminals and the technology of vessels. We have chosen low-pressure ships, and this is a big discussion in the business, low pressure versus medium pressure, mostly, and the whole discussion started because medium pressure was the way that the few liquid CO2 carriers that were out there for the food and beverage industry were built. And the industry chose to go for what is the established way, at least as a first step, when it came to the only project that has materialized so far when it comes to maritime transportation, which is the Northern Lights project. But if we want to achieve what I mentioned before, so movement of the liquid CO2 in bulk, in large volumes, over longer distances, which also my fellow panelists outlined as a major need for the industry, it is, I think, an imperative to move towards low pressure. Low pressure has, I would say, two major advantages. Firstly, the capex is about 20-25% cheaper compared to medium pressure ships. So when you order a ship, you can order it for less. It's as simple as that. And also, a low-pressure ship can carry about 10% more because of the pressure and temperature combination compared to a medium-pressure ship. By now, it has been firmly established that low-pressure ships can be very effective. And in reality, if you want to build a ship larger than, let's say, 25,000 cubic ships, which is probably what we will need, especially in the Asia-Pacific region, but potentially also in Europe, you can only build low-pressure ships. So I think in order to be able to move liquid CO2, so really waste, efficiently, we need to make sure that we minimize, I mean, as far as the shipping is concerned, we minimize cost by standardization and using the most efficient technology out there.
Mr. Heikens, can you adapt to this question by focusing in particular on the commercial viability of future solutions in the CCS value chain in the Mediterranean? And please give us also some insight about challenges that have to do with cross-border CO2 transport, because you mentioned it in the previous question.
Well, first of all, I fully agree with the low pressure, by the way, so thank you very much for that. Our terminal that we're developing for 5 million tons with 50,000 cubic meter storage will be a low pressure design, and certainly that's what we're trying to advocate in our chain and with our partners for exactly those reasons. So that's great. But just on the chain, because on the economic viability, like, you know, in reality, the chain doesn't pay for itself anymore at this stage. If you look at carbon capture, transportation by pipe or liquefaction, shipping, and then sequestration, the cost of all of that is not covered under ETS today. You know, with ETS at 80, 90, or even 100, we still can't really afford that. There's quite a bit of variability, of course, in the capture costs of different emitters. That will drive the whole chain cost. But in general, we're not there yet, which is not entirely surprising, right? Because all this technology is new. The industry doesn't exist yet. There's no playbook to go by. Like, that's how they've been doing it for 30 years over there, or that's how they do it over there. So let's just do something that looks like both of them, but then better. There's nothing like that you can do. Everything is, trying to invent the wheel to a degree from start, based on known technologies, but the combination of all of it is new. So getting support from governments is really, really essential to get a chain started. We, in our project in Greece, together with DESFA, who are our partners, we've been fortunate enough to receive RRF funding, just like the Athenaeum project, which really helps with paying for the pipeline to connect several emitters in Greece. As a project, we've also applied for innovation funding with the EU, which is a big pot of funding, grant funding that we'll hopefully in the next few weeks learn more about. And George at the end received funding from that last year. And then because we're also a PCI project of common interest in the EU, we'll also be applying for CEF funding now in October. So hopefully with grant funding from several pots in the EU, funding from the Greek government, and then our own funding, of course, hopefully that will help these projects come off the ground. But there's still a long way to go in that respect. But this is not new. We've seen this in the wind sector, offshore wind sector, solar sectors. They all needed support to start. And look where wind and solar are now, right? I mean, they're beating all other energy producers. But so we're looking at innovation within the chain, going to low pressure ships, moving away from medium pressure, which were the first ones, is already a big step in innovation and already 25% reduction in cost. So we're seeing all these steps will happen. The cost of these chains will go down. The ETS price will go up, and hopefully soon, thinking about my shareholders, hopefully soon those 2 points will converge and we have a project that is economically viable. Other areas to think about that are going to improve this is more storage, like Nikolas just said earlier, and opening up to areas outside of the EU for storage. He mentioned Egypt, he mentioned North Africa, but those are no-go areas at the moment for volumes out of the EU. The EU policy is that CO2 has to stay within sequestration sites in the EU to be counted as not emitted. That's a real burden for Mediterranean emitters. It's less of a burden for emitters in the northern European side of Europe. So pushing open that door with the EU policymakers to allow indeed European CO2 to go to North Africa is going to be essential to decarbonize about 280 million tons of CO2. That's within the European side of the Mediterranean. Because in general, if you look at past oil and gas exploration, you'll see that the northern side of the Mediterranean, the European side, is very, very limited oil and gas fields. It's all on the southern side of the Mediterranean in North Africa. So, you can quite easily determine from that CCS opportunities for sequestration are going to be much more plentiful in the North African side of the Mediterranean than in the European side. But the EU policymakers and, in my view, emitters in the Mediterranean need to push with the EU, with Brussels, to open that up.
Thank you. And Ms. Polychronopoulou, please comment on that. All this landscape, we have just thrown all the cards on the table. So what about what role do you see for partnerships with emitters and integrators to drive technological innovations?
We need all the stakeholders. We need to be allowed to make mistakes that will not penalize, not us, the developers, and most importantly, not the ship owners or the emitters in general. So we need a lot of support to make sure that we will be able to install as many systems as possible, to make mistakes that can be rectified. We need to make sure that we have the best possible solutions on board, and we have to use the systems in order to understand where we stand, what we can do better, where we can have less energy, where we can have less steam, where we can have less space. So we need all this support in order to move forward. But we also need standards. Where do we offload, not only as the connection, but also what quality is needed for the sequestration, what quality is needed for utilization. There is so much discussion going on regarding the percentage of purity of CO2 that does not allow for a straightforward solution. So as you can understand, we cannot have solutions that are adapting to each terminal. It's not possible to change the quality of the CO2 produced according to your destination. So we cannot have China asking for 95% and then Europe asking for 99.95%. This is not possible. So except everything that has been discussed, we need also support, and we need standards as well.
Thank you. That's a very good piece for companies like ours. So taking this to the next level, to Mr. Rigas, what are the biggest barriers from your perspective with regards to effective collaboration between emitters, technology providers, all the members of the value chain?
When we talk about collaboration, I think it's the most important thing to talk about when it comes to developing a carbon storage value chain. We talk about, and I give this as an example very often, it's the chicken and egg situation that we have here. An emitter will not take FID unless they have a storage site. A storage site will not take FID unless they have an emitter. We will neither do anything unless we have government funding. Gathering terminals and liquefaction terminals will not take FID unless the value chain is there. And we're sitting in a situation where you pass the ball around and you're saying, oh, they're more delayed, and it just gets pushed down the road. So collaboration in terms of getting the project done is the only way possible to do it. If we don't collaborate as an industry to bootstart the industry, it's not going to happen. And to give a nice example, given we're in a shipping forum, if you take a look back in how the LNG market started, it started in a very similar way. One liquefaction plant, one carrier, one regasification terminal to kick it off. And then this turned into a global industry with hundreds of thousands of ships around the world at the moment, transporting a commodity, which is now LNG. CO2 is going to start in a very similar way in our view. And there are a lot of questions, LP, MP that's been discussed now, what temperature, what pressure is it going to be in, how is it going to be carried around? Short distance prefers medium pressure, long distance prefers low pressure. What are the specs going to be? And when it comes to specs, when you're designing a facility that's going to be there for the next 25, 30 years, you need a facility that's going to be able to accommodate everyone, technological advancements. But in the end of the day, who's going to bear the cost for this? Because I can make a pipeline that's made out of gold and can take any spec of CO2 you want in there, but then I'm going to have to pass it on the cost to my tariff. So the question is to collaborate and come up with a value chain cost, which is the best optimization scenario. What's the cheapest way to capture it, transport it, and store it all together in order to come up with a common solution that's the cheapest way possible? And as you said before, it's not a product that we're creating here. It's decarbonizing the industry. It's already very expensive to do so. The goal here is to find the cheapest way possible.
Mr. Daskalakis, I think that you can give us a closing comment, which is actually on your broad decarb strategy, your company broad decarb strategy. How do you see all these solutions fit into the strategy? I think this is a very good takeaway. I mean, given what we have discussed about the maturity level of each and every aspect of the value chain, the challenges, the technical, the regulatory ones.
The thing is that we have an obligation. We are participating. Our starting point is that we are participating in this emission trading system. Something that appears to be very, a defining factor for our financial situation in the coming year. Right now, it is not. Right now, the ETS is sleeping, and it does not send the signals required to, you know. But in any way, taking into account this, that we need to decarbonize our operations, meaning the scope 1 of emissions and scope 2 emissions, indirect emissions. We have mobilized several technologies, meaning starting from the very fundamentals like energy efficiency, cleaning, and so on, our exchanges, up to the very biggest one that it's called carbon capture and use. We selected carbon capture because on this specific unit, because we emit something like 2.3 million tons of CO2 out of 15 emitting points. So we are not lucky to have just one emitting point. So ranking these emitting points, we said, okay, SMR is the one that needs to be decarbonized because it provides us the flow requirements, the CO2 concentration, the impurities there and the flue gases can be regulated. And on top of that, we will be producing low carbon hydrogen, which at that point, it was very important for us. And we were considering the blue hydrogen, the production of blue hydrogen, as a way out in the market of hydrogen, as it was developing by that time. Then, now, as it develops right now, we have a decarbonized unit, 25%. We will be producing a very clean molecule, hydrogen. We have the opportunity to decarbonize other units downstream by using it as a fuel and decarbonizing our products. Then we needed to do something with this, as I told you in my opening statement, and we, focused on what is in the market. And then the focus came on the methanol, because we are actually using methanol. So it's, but at the same time, there's perspective out that the methanol may be a future for fuel for the maritime industry. So, taking into account that we had already started the construction of a 30 megawatt electrolyzer for green hydrogen this time, not blue, and the existence of the legal framework there, we will now be able to produce a green fuel of a low carbon intensity, which actually focuses and targets our scope 3 emissions, meaning the emissions coming from the use of our products. Of course, the emissions coming out of the use of the products are much larger than the production, but still, this is our opening, the first step that we are doing there. So, and also with the blue hydrogen, we are developing all the corresponding infrastructure for dispatching CO2, compressed hydrogen to industrial consumers, as well to 2 different hydrogen refueling stations that we are constructing. So with this, we see carbon capture becoming a lever for our decarbonization, spanning from scope 1 to scope 3, and as well as bringing in technologies that have not been used again before, like the e-methanol. Then following the e-methanol, which is a very simple molecule, we can move on to DME, we can move on to kerosene, and so on. And it's a learning path. Actually, we need to understand that we are discussing about very inefficient technologies for the time being, but given that part of them are funded by the EU programs, this eases the thing. Of course, the costs still remain on the red. This is something
Thank you.
that needs to be fully understood.
I hope that we have given you a very good overview of the challenges, the current status, and the opportunities which exist there for all about carbon. Thank you. Thank you all for being here.
Thank you very much.